Let's talk now about the certification process. And the certification process connects together the result of the MRB with the role of the manufacturer. Let's look at some background documentation. We've got airworthiness limitations, and they come from a range of different sources. Structures airworthiness limitation, flight manual limitation, certification maintenance requirements, CMRs, fuel system limitation, critical design configuration control limitation. When we talk about the criteria by which we develop aircraft, we reference to a requirement which is CS Certification Specification 251309, and it's a direct equivalent of FAR 251309, and it requires that systems and installations are designed to ensure that aircraft operating safety is not compromised. So let's consider an example. How often will we experience the failure of a component within the autopilot system? And it may be that once in 1,000 flights we will have a failure of the autopilot system. So the failure rate would be 10 to the minus 3. And if we look at this and rewrite it in a particular way, that means that in 1,000 flights we will have an autopilot defect. Is it a problem? It's not a problem. We have multiple autopilot systems and we can live with this. But what about if the aeroplane is doing an automatic landing and it's foggy and we can't see anything and we're relying on the autopilot to get the aeroplane safely on the ground? So every 1,000 flights we're going to lose an aeroplane. So that doesn't work. So when we apply the criteria of CS 251309, we start to understand that a system that is essential to the safety of the aeroplane, we're looking for a safety of 10 to the minus 9. What that means is that we shouldn't have an incident in 1,000 million flights. So we've gone from 1,000 flights, 10 to the minus 3, to 1,000 million flights. Now that's a better story. And in actual fact, when we look at the autopilot, we say, okay, we need to think of a clever way of getting the autopilot to land the aeroplane. So we have autopilot 1 and autopilot 2. We have two computers, and we said, how about when we're auto-landing that both the computers work together? So for auto-land, we have autopilot 1 plus autopilot 2. But in actual fact, it's still not okay, because we've got 10 to the minus 6. Means 1 in a million flights we're going to have a problem. So it's still not okay. How about if inside autopilot 1 we have channel A and channel B? Channel A and channel B. And how about if for the most important phase of the landing that one channel can land the aeroplane? Just one channel is enough working to land the aeroplane. And each channel is talking to the flying controls, telling the flying controls what to do, and it will land the aeroplane successfully. Now we've got a different story. Now we've got 10 to the minus 3, 10 to the minus 3, 10 to the minus 3, and that gives us 10 to the minus 12. Means the chances of an autopilot failing now is in 1 million flights. So that works. And that's the rationale that is applied to the entire process of developing the aircraft and the aircraft systems. That's the level of safety that has to be built in. So, failures of systems that do not have a significant effect can be tolerated. Failures of systems that could cause catastrophic outcome cannot be tolerated. And that's the basis of how that process works. The aircraft and its systems must perform essential function under any foreseeable operating condition. Occurrence of failure which prevent continued flight and safe landing must be extremely improbable, 10 to the minus 9. Occurrence of other failure conditions which reduce capability of the crew to cope should be between 10 to the minus 5 and 10 to the minus 8. System installation must provide warning information to alert the crew to unsafe system operating conditions. Compliance shown by analysis and, where appropriate, suitable tests, which is why it takes several years to introduce an aeroplane.